Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the fourth of 6 videos in the number and operations grouping. The video is about adding within 100. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the standard that this video is based upon follows at the end of the video. The standard that we're going to look at in this video is adding within 100, and we'll be using 3 different examples. One will be using a 2-digit number and adding that with a 1-digit number. Another example will be using a 2-digit number and adding it with a multiple of 10. And the third type of example that we'll look at will be adding 2-digit numbers. And we'll show each of these examples in 3 different ways. One will be using a 10 frame, another will be using base 10 blocks, and the third way will be using number lines. So for starters, let's look at 27 plus 8. And whenever we're doing this, we're always going to add our 10s plus 10s and our 1s plus 1s. So in this particular case, 27 plus 8, well, the only 10s are in 27, and then we have to add our 1s, our 8 ones here, plus the 7 ones in 27. And we're going to use our 10 frame and the counters within the 10 frame to help us. So here we have 7 ones. So what we want to try to do is complete the 10 frame. And what we can do is we can take some of the counters from our number 8 and move them into the counters along with the 7 that are here. So we're going to move 2 more counters over. One more to move. Okay, and now when we do this, we've done our addition, and we can count up now our 10s. Now we have 1, 2, 3 10s, or 30, plus 5 1s. So that's a total of 35. So when we're adding 27 plus 8, using our 10 frames and our counters to help us, we've added a 2-digit plus a 1-digit number, and the answer is 35. Now, staying with our 10 frames and our counters, we'll add a 2-digit number to a multiple of 10. So now we're looking at 27 plus 30. So once again, we want to add 10s with 10s and 1s with 1s. So when we add our 10s, we see that we have 1, 2, 3, 4, 5 10s, or 10, 20, 30, 40, 50. And the only ones that we have are the ones in the number 27. We have 7 ones. We have 7 counters up here. So we have a total of 5 groups of 10, 50, plus the 7. So 27 plus 30 is equal to 57. So now we'll use an example of 2-digit numbers and add them both together. So we have the numbers 27 and 34, and they're represented here by counters in using our 10 frames. 2 10s and 7 1s, and 3 10s and 4 1s. And the first thing we want to do is we want to see if we can compose any 10s. In other words, take a look at our 1s and see if we have enough 1s to make a 10. And we have the 7 1s, and we have 3 more open spaces to make a 10. So we do have enough counters to fill up another 10. So that's what we'll do first. We'll fill up this 10 frame on the top. And once we do that, we can now go ahead and count our tens to tens and see how many ones we have left. So we have 1, 2, 3, 4, 5, 6 tens, or 10, 20, 30, 40, 50, 60. So that's 6 tens, and we have 1 1 also. So 27 plus 34, that would be equal to 61. So now we can use the same examples, but show these examples by using base 10 blocks. And it's very similar to using the counters and the 10 frames. So here we have 27 plus 8. And what we're going to try to do is we're going to look and see if we can compose and make a 10. Same thing we did with the counters and the 10 frames. So we're going to move these ones up here to compose or to make a 10. And our first graders, right here, we're using our base 10 blocks, but the hope is the first graders will then be able to represent these base 10 blocks in drawings so that they'll be able to, for instance, the tens, maybe draw two rectangles, and they'll be able to draw cubes for the ones, and then advance from that and maybe represent the tens just with a straight line down. And as far as the ones, maybe with just dots. And that way, there in their minds, they can be seeing the base 10 blocks, but they're just using paper and pencil to represent the base 10 blocks. And then, of course, the progression from there is to get away from the representation and then just to be able to do it. But using the base 10 blocks, what we've now done is we have 10 ones. Let's see what we can do with those 10 ones. Those 10 ones, we will now turn that into 110. We'll place it in the tens frame, and now we can get the sum of 27 plus 8, and we now see that it's 3 tens plus 5 ones, or we have the answer of 35. And now we have our example of adding a two-digit number with a multiple of 10. So 27, maybe our first grader would be able to represent that number by drawing two rectangles, two long rectangles, or maybe just two lines for the 2 or 20, and for this digit 7 by drawing two squares, or maybe just drawing, 7 squares, or maybe just 7 dots. So now we're going to combine ours ones, we just have the 7 ones. And for the tens, we have 1, 2, 3, 4, 5 tens, or 50 plus 7. So 27 plus 30 will be equal to 57. And for our final example using base 10 blocks, we have the example using two-digit numbers. So we have 27 plus 34. And by looking at 27 plus 34, we have 2 tens plus 7 ones. And for 34, we have 3 tens plus 4 ones. And remember, we want to add tens plus tens and ones plus ones. But first, we want to see if we can compose and make another 10 by looking at our ones and seeing if we have enough ones in the number 4 to add to our 7 ones. And we see here we could add 3 more ones to the 7, and that would make 10 ones and compose a 10. So that's what I'm going to do. I'm going to take 3 of our ones from our digit 4 and move it up here. And once again, with our first grader, if our first grader can be representing this on paper and pencil and not needing the base 10 blocks, they may be representing these tens by using long rectangles or maybe just a long line. And for the ones, they could be drawing squares, or they can simplify it and just draw dots to represent the ones. And then what they also could do, if they're using pencil and paper, if they had the 4 ones here, they might be able to cross out 3 of them and then add those 3 ones here so that now they have 10 ones here. And then what they could do is maybe circle these 10 ones, and then these 10 ones could then be crossed off. It creates a 10. They can create that 10 or that long line over in the tens place, and now they can count their tens and their ones and come up with their answer. They have 1, 2, 3, 4, 5, 6 tens or 60 plus the 1, 1. So as far as for the answer now, they know that 27 plus 34 will be equal to 61. As an addendum to this video, I want to tie in what we want first graders to understand with the traditional way that you may have approached some of these problems. So let's take a look at the example 27 plus 8. And traditionally, we might hear people saying 7 plus 8 is 15. Put down the 5, carry the 1. 1 plus 2 is 3. And there's our answer, 35. Well, when we look at this, 7 plus 8 is 5, and we carry the 1. I'm not so sure where are we carrying it to, and do our first graders know where we're carrying this to? And is this really a 1? And when we put down a 5 and we, quote, carry the 1, first graders might think, geez, 5 plus 1 is 6, not 15. And then we're adding 1 plus 2, and that equals 3. And we've got the 3 here and the 5 here. Why is that really 35? So I'm being a little facetious here, but the goal is we really want students to understand what they're doing. And yes, ultimately, we want them to be getting to the exact same answer and doing it efficiently, just like we did right here, and we efficiently got to the answer of 35. But we really want them to do, our first graders to do it with an understanding of our number system. And that will really help them understand not only the number system, but ultimately make it easier for them to really understand future math concepts. So what our first graders are doing is really the same as the traditional algorithm. Basically, they are looking at these ones and they see 7 ones and they see 8 ones. And if they're not sure how much 7 plus 8 is equal to, well, they're filling in a 10 frame to see if they can make a 10 out of 7 plus 8. And when they do this, they see that they are able to make a 10. So they have 110 and they have 5 ones. So the 5 ones is brought down as 5 ones, and then the 110 will actually show as a 10. These 10 ones now becomes 110, and we'll bring it to the 10 side. So we really want the first graders to understand the digits in this place represent ones. This is 7 ones. This is 8 ones. This is 5 ones. So we have these 5 ones I now brought down here so I can get rid of these 5 ones. And we have our 110. So this is the same as when we wrote down 5 for an answer here, and we, quote, carried the 1. Well, what we did is we actually brought up the 1, but this 1 represents 110. And now what we're going to do is we're going to add the digits in our 10 column. When we're adding 1 plus 2, we want our first graders to understand that we're adding 110 plus 2 tens, and that's now going to be equal to 3, but this represents 3 tens. So 27 plus 8, we can all agree equals 35. The third way that I was going to show you how your first grader could add was by using a number line, but I'm going to hold off in doing that and I'll address it in the next video when I discuss the next standard because the next standard includes mentally being able to add by 10, and I think it's critical that the first graders be able to do that, and once they're able to do that, it'll be easier for them to use a number line to add multiples of 10 or to add two-digit numbers. So we'll hold off on that for now and address it during the next video. If you're interested, here's the complete standard that this video, Adding Within 100, is based upon. Add within 100, including adding a two-digit number and a one-digit number, and adding a two-digit number and a multiple of 10, using concrete models or drawings and strategies based on place value, properties of operations, and/or the relationship between addition and subtraction. Relate the strategy to a written method and explain the reasoning used. Understand that in adding two-digit numbers, one adds tens and tens, ones and ones, and sometimes it is necessary to compose a 10.